I've built lots of projects that use an Arduino or an ESP32 to light up patterns on a programmable LED strip. And I normally do this using the FastLED library, which is great. It's reliable, it's fast, and it provides the functions that generate the data signal required for lots of different sorts of programmable LED chips that you can then integrate into your own code. And if you're using LEDs as a direct indicator of some sort of input or to represent the state of a controller, that makes a lot of sense. But it does mean that your lighting effects are hard-coded alongside your program code. So every time you want to modify a colour or tweak the timing of an animation or add a new effect, you have to edit your code, recompile it and reflash it back onto the device. So the purely visual aesthetics of the lighting and the logical functionality of your code have become tightly coupled together. And that makes your project more fragile, and it means that the process of adjusting the visual appearance becomes very clunky. It also means that your ability to use more complex lighting effects is constrained because of the limited processor and memory resources available on something like an ESP32, which are already being used up doing other tasks like listening for button inputs. So in this video I'm going to describe an alternative approach. I'm still using an ESP32 to control the LEDs, but instead of it also calculating the lighting patterns, I'm doing that remotely on software running on a PC. So this software then sends the data to the microcontroller using a protocol called sACN. The ESP32 only needs to retrieve that data and then send the RGB values out to the LED strip or any other lighting fixture. So instead of acting as a lighting brain, the ESP32 just becomes a dumb networked lighting node, which is much closer to the way that stage lighting fixtures would work in a theatre. And because the lighting is being calculated on a more powerful PC, it means I can do things like encode a video stream or an animation or a complex image into RGB pixels and then send them to a more complex LED matrix. So this LED matrix I've got behind me here, this has 1536 pixels in it. And I can update them at a range of 40 frames per second, which is way faster than the little ESP32 could manage. All of the software I'm using to do this is completely freely available on the internet, so let's get going. So let me say some more about the sACN format, which I'm using to send data from the PC to the ESP32. Now, you may be familiar with DMX, which I've used a couple of times in my videos. Traditional DMX connects lighting fixtures together using one cable, which carries one universe of data. And a universe consists of 512 channels, each of which is a value somewhere between 0 and 255. Now, all of your lighting fixtures are connected in series using physical daisy chain wiring. So if you're controlling something like a DMX spotlight that only requires a single channel of data to control its brightness, with a value of 0 being off and 255 being maximum on, and all the values in between are increasing levels of brightness. And you could control 512 of those spotlight fixtures using a single universe of DMX. But when it comes to controlling LEDs, each LED has a red, a green and a blue intensity value. So that's 3 channels of data. And that means that one DMX universe can only control a maximum of 170 LEDs. And because LEDs are typically quite small, high density fixtures, that might only get you a couple of meters worth of lighting effects. And you can't send more than that down a single DMX cable. So enter sACN. sACN stands for Streaming Architecture for Control Networks, and it's defined by the ANSI standard E1.31. sACN retains a lot of the structure of DMX data, but it delivers it over Ethernet. Now I should clarify that somewhat, because you can get adapters like this which let you send DMX data over a Cat5 or Cat6 Ethernet cable, but it's still just using the same DMX protocol in a different cable. sACN is slightly different. It delivers packets of data which still consist of universes, and each universe still has 512 channels, but in a single Ethernet cable you can send hundreds or even thousands of those universes, and the devices that receive them don't have to be daisy-chained together in series as they are with DMX. They can use a wired or a wireless connection to a regular Ethernet network. So just using a PC and a network router, you can have as many lighting nodes as you want, all controlled centrally. And this is much more like the way that lights in a modern club or theatre or live performance are configured. Now let me demonstrate some software you can use to create and send sACN data to the ESP32. And because, as I mentioned, sACN is an ANSI standard, there's loads of different software packages that support it. There's commercial software like Madrix, Touch Designer, MadMapper, but there's also plenty of free and open source alternatives. And in the video just now, I was using something called Jinx, which is specifically designed for controlling LED matrices. So let me just step through how you can configure it and some of the options available. So the first thing you're going to want to do is to configure the matrix you're using. The one I've used here is 48 pixels wide and 32 pixels high, giving me a total pixel count of 1536. The maximum allowable, it says here, is 48,000, so I've still got some way to go before I reach that. And then I need to define the output I'm going to use. So as I mentioned, sACN still is based on the concept of universes, and each universe has 512 channels of data. So to send the data for my 1500 pixels, I'm going to need a total of 10 universes, because each LED is going to need 3 channels of data, an R, G and B value. And I'm using the IP address 192.168.4.2. So sACN supports what's both called multicast and unicast addressing. So multicast is a bit like sort of just sending data out to the group, and the individual devices choose which data from the pool they want to use, whereas unicast is more like targeted addressing of a particular fixture. Now, rather than joining a network, I've actually directly wired my PC to my ESP32 here via a Ethernet cable. So what I've done is I've added a static IP address for my PC here, 192.168.4.1, and then I'm going to add a static IP address for the ESP32 as well, which is 192.168.4.2. So I'm using unicast addressing, but you can use either way. And all 10 of my universes are going to get sent to that same device. Now I need to create a patch, and a patch explains how the individual values on the arrangement of the matrix correspond to the channels in the different universes I've used. So here we've got a big matrix which represents my LED display. It's got my 48 columns and my 32 rows. And these are all green at the moment because they have all been patched. But if I click on one of these values here, you can see that this LED at the top left-hand corner, I'm going to patch that to my first universe, and the first channel is going to be red, then green, then blue. So the first 3 channels from this universe are going to be used to populate this pixel here. And then if I go along, you can see I'm then using the 3rd, 4th and 5th channels, etc, etc. So this goes all the way down my first universe until I run out of channels, which is going to happen just here. So this pixel here in column 26, row 4, up to now I've only been using my first universe, but at this point I'm going to go over to use the first 3 channels from my second universe of data instead. I'm just going to carry that all the way down right into the bottom corner here, where you can see I've just finished the 9th universe here, and then my very last few pixels I have to break into the 10th universe. And you can assign these manually if you want. You can just choose the drop down here and you can select the channel values, but there is this option for fast patch, which will let you fill a sub array of your matrix, and you can specify how your wiring of your pixels is done, whether it's done line wise or as snakes backwards and forwards, top left to bottom right or the other way around. And also you can change the byte ordering depending on the way that your strip is wired, whether it is red, green, blue or green, blue, red. One thing I will mention now is that my ESP32 also has the option to correct byte ordering, and you don't want to do it in both places. So my strips aren't actually using RGB pixel order, they're using BGR. But at this point here, I don't want to convert them twice, so I'm just keeping them as RGB. So that is my matrix and my output setup. Then I can choose the sequences which I want to do. And you can see you've got 3 panels here. This is a bit like a mixing desk. You've got the left-hand side channel, which let's say I want to use a fire effect or something like that. On the right-hand channel, I could have something like falling rain instead. And in the middle here, I've got a slider which I can slide between those 2 effects. And in fact, even on the left and the right-hand side channels, I have a sub effect here. So let's say I want to use an image, and I'll choose just an animated GIF, which I've added earlier. So all the way over to the left, I can actually adjust the mix between my fire and my dancing effect here, and then I can separately also combine my 3rd effect from the right hand side here. And this will send out this data as sACN as soon as I click this start output here, and the lighting fixture on the network, which is assigned to the IP address which I've chosen here, will start receiving that data. So now let's talk about that receiving device which is driving the LED matrix. If I spin this round, you can see it's formed from 6 panels. Each one is a 16 by 16 WS2812B LED matrix, which are wired together in series. And the data signal is being sent by this white controller at the bottom. This is a WLED Opto ESP32 LED controller. And you could use any ESP32 board or another microcontroller here if you wanted. The reason why I'm using this one is because it's nicely packaged. You can power it from USB-C or a 12-volt power source. It's got an external fuse for protection. It's got Wago push-in connectors for easy wiring and a built-in Ethernet connector, so it can receive that sACN data over a wired Ethernet rather than relying on wireless. And if I show you what it looks like inside, you can see it's got power regulation circuitry, a quad buffer logic converter so that all 4 output ports get the correct 5-volt signal on the data line, and selectable series resistors between 33 and 249 ohm, depending on what sort of LEDs you're trying to drive. So it's a really nice bit of hardware, and it comes pre-flashed with software called WLED, which is what I'm going to use to receive the sACN data and send it out to the LEDs. And now if I open a web browser and go to the IP address of the ESP32, you'll see that I get a message that WLED is receiving live data from the IP address of the machine that's running Jinx, and that's what's sending the sACN data. Now, one of the features I really like about WLED is that it has the ability to preview what that data looks like. So if you click the peek button here, you'll see you get a visualization of the LED matrix. And now if I just minimize the browser slightly here, so here in the background I've got Jinx sending the data. This window here is showing how WLED receives it, and then I'll put a video in the corner to show that how the LED matrix is overlaying it as well. And now if I just adjust the values in Jinx here, so I'll bring the slider across to send this sine wave pattern instead, you can see that WLED receives a sine pattern and then it appears on the LED matrix as well. So that's just a really nice feature that allows you to debug the patterns even without having any hardware attached. You can see a preview of how it's going to appear. Now, in terms of the WLED settings as well, There are a ton of features. So the principal setup is to come into this settings here. This is where I've defined the IP address that I put into Jinx, that I'm targeting this device. The gateway is my PC itself. Like I say, I'm running a local link interface directly between the PC and the ESP32, but if you have them both on the same network, you'd put that as the gateway of your router instead. And you can leave all the other settings there the same. We go into the LED preferences, and this is where I specify the parameters of the actual hardware I'm using. So my LED matrix is made of WS2812B LEDs. And as I mentioned, these are actually in GRB byte ordering. But in Jinx, I was keeping it as RGB, because if I set the channel order there as GRB and then also this channel order here as GRB, they'd get flipped twice. I don't want that to happen. So I've got just the settings here of the byte ordering. I'm using a single GPIO output from the WLED Opto device. It's on 16. But I do need to specify how my matrix is created. So I've composed this matrix out of 6 16 by 16 panels. They're all arranged in serpentine orientation, so the LEDs on each panel sort of follow an S shape backwards and forwards like this. And the entire setup looks like this. So this is my first panel, which when viewed from the front is in the top right corner. And the green here shows the first LED of that panel. So this is LED 0, and it snakes down the first panel until it gets to here. And then we start on the next panel up here, all the way down to the bottom. And so my last LED, if this was a strip, if you were to unravel this into a linear strip, it would start here and end at the bottom here. And that is my 1536 LEDs. If you use, let's say you actually just had a lot of strips instead that were in straight horizontal lines or vertical lines even, you could adapt the settings here to say whether they start at the left or right, whether they were vertical or whether they were serpentine or not, to specify the actual way that your LEDs are mapped into your matrix. So that's the setup there. And then we go into sync interfaces. So WLED is actually really powerful. It's capable of receiving lots of different sorts of input. We're using it for sACN. If you have an older ArtNet was a proprietary standard that sort of came between DMX and sACN, and some devices still use it, so you could use it for ArtNet instead. It also receives MQTT messages, so you could control it directly from Node-RED if you want. It allows serial interfaces, Philips Hue interfaces, and lots of other sorts of LEDs can be controlled as well, not just WS2812B, which is what I'm using, but you can use LEDs with separate clock and data lines. So it's really great. It does have a bit of overhead. If you wanted a much more refined system, you could implement something like the ESP Async E131 library, which is a lot more minimal, a lot more lightweight, but you wouldn't get all these features, all of the different previews. You wouldn't get things like the peak function to be able to preview what the data coming in is. So although in one sense using something like WLED is overkill, it actually comes with all its own built-in patterns as well, which I'm not even making use of here because I'm streaming the data direct. But I do think it's a very, very simple setup. It's really well supported. It's got lots of documentation. So I do recommend starting with this and only upgrading if you feel that you need to get something a little bit more performant. But yeah, I'm really impressed by it. It's great. And you can network several WLED devices together. And if you find that you want to control more LEDs than you can from a single output pin of your ESP32, that's fine. You can add more data pins, so you can have several chains, each one controlling its own LED strip. So you can run up to about 3,000, 4,000 LEDs from a single ESP32 here, depending on what frame rate you want to maintain. So if up to now you've been hard coding your LED animations into your ESP32 or Arduino code, I hope that this video has given you some ideas as to how you can create more complex LED animations using dedicated lighting software, and then just streaming that data to the microcontroller using sACN. And this really is a gateway to a whole lot more interesting lighting effects that you can create. Things like projection mapping and volumetric lighting, which are topics which I'd like to cover in future videos. So if you're interested in those kind of things, please do subscribe to the channel. Now, I've only really been able to cover a very brief introduction to some of the more technical details involved here. So if you've still got questions, please do write them in the comments below, or else you can join the Discord server, and I'll put a link to that in the description, which is a great way to connect to people all over the world who are making really interesting, exciting, creative technology projects. Now, I'll put a link to the code and the resources that accompany this project over on my Patreon account, where you can also download resources for all of the projects I've made in this channel. I'm only able to create these tutorials each month with the very generous support of my Patreon donors, so I want to take this opportunity to say thank you all very much. I really do appreciate your support. Other than that, I just want to say thank you all very much for watching, and I look forward to seeing you next time. Okay, cheers, bye.